Bismillahirrahmanirrahim. Dear students, let's talk about D sections assignment. So the first problem of this assignment has a cantilever beam subjected to a VDL. Magnitude of the UDL or the intensity of UDL is 9 kilonewton per meter. It's a cantilever beam, so a vertical reaction at support A will be generated and a reactive movement will also be generated. I have roughly seen the calculations and I think the reaction values are correct. RA is 27 and MA is 108 kilonewton meter. And then in this case, we just need to consider one portion, AB. The entire beam will be a part of one portion, single portion. And the shear force diagram is second degree, and at the free end it's equal to 0. Bending moment diagram is third degree, and at free end it's equal to 0. So both are correct. In the elastic curve, the curve seems more like a straight line and it is starting right from the beginning. That's not correct. So I have corrected the elastic curve. It will start rotating after some distance from the support, and then the beam will be hogging. So that's the correction in the elastic curve. Then the next problem, in this case we have a simply supported beam subjected to a point load at the center and a couple. In this case we will make two portions, AC and CB. The reaction calculation, I think these reactions are correct, 3.5 and 6.5. And then we write down the equations for shear and bending moment. The shear force diagram for this beam is also correct. Sorry, 3.5 on this side, 6.5 on this side. Bending moment diagram also seems fine. It's a simply supported beam subjected to a load in the downward direction, and the tendency of the movement is also sagging. So the entire diagram, I expect that it should be positive, and the difference between these two values is equal to the couple, and the values of movements at the ends are 0. So this diagram seems correct, and the elastic curve is also correct because the entire bending moment diagram is positive. So entire sagging curve is also fine. Next problem is a simply supported beam subjected to 3 movements. And if we calculate the reactions for this condition, we get RA and RB both equal to 0, which makes the situation quite simple. So if you write down all the equations and then you draw shear force and bending moment diagrams, the shear force comes out to be 0 and bending moment diagram is entire positive. So the entire sagging elastic curve is also fine. The ordinates of this bending moment diagram also seems correct. Next is problem number 17. It's a cantilever beam with a single point load acting at the extreme end. Magnitude of the load is not given, rather it's a variable P. So the reaction calculation is correct here. And then if we look at the shear force diagram, bending moment diagram, these diagrams are also correct. But in the elastic curve, I have the same observation again. The rotation of the elastic curve should not start right from the support because it's a fixed support, and it should be hogging throughout the length. Although we just draw it like freestyle, but the tendency of the deflection should be correct. Like sagging should look like sagging and hogging should look like hogging. So I think this would be a better elastic curve. Initial small portion should be straight, and then it should start rotating, and the entire beam is hogging. Then we have problem number 21. We have a simply supported beam subjected to a UDL close to center, not exactly at the center. So reactions are not exactly equal to each other, 13.1 and 10.9. These reactions seems okay. And then if we consider all the portions and write down the equations, then we get this type of shear force diagram. The shape of shear force diagram is correct. Shape of bending moment diagram also seems correct, but I did not see the calculations here for the location of this point, because this situation is not exactly symmetrical. This ordinate is 13.1 here and it's 10.9 here, so this point will not be exactly at the center of this 4 meter, rather it will have some offset. In order to calculate that, we need to put the shear force equation for this portion equal to 0, and that will give us the location of this point with respect to this end. Then we'll mark it here, and then the corresponding point will be put into the bending moment equation of this portion, and then we'll get this peak. So I couldn't find that calculation here. I'm not sure if it's done here or not, but that's the right way to do this. I'm not sure if this value is correct, so please verify this value. And the entire bending moment diagram is positive, so a sagging elastic curve is fine. And this problem is same for the other section, and it's already discussed in the solution of that section's assignment. So with this, our discussion about D section's assignment is also complete. And if you guys have any query about these assignments, we'll talk about them in our class meeting on Teams. Okay, thank you very much.